idea, write down angle of intersection of two curves. We know that angle means something which will have two arms, linear arms with a common vertex. Then only we can think of angle. So what is angle of intersection of two curves? That's been justified by that at the common point of two curves, if we draw tangents to both the curves, then the angle between the tangents, also known as the angle of intersection for the curves. You can identify here we are dealing with two curves. One is a violet curve and the other one is a blue curve. And they do have their common point at P. This is an intersection point. So P is that common intersection point. So from P point, we have drawn tangent for the blue curve and tangent for the violet curve. So whatever angle we have got between these two tangents, if I mark that as theta, so over here we will mark that the angle of intersection of the two curves is theta. Okay. In particular, if this theta is right angle, then we mark the curves as orthogonal, or we say the curves are intersecting orthogonally. Okay. So when the angle of intersection of the two curves is the right angle, then we call such curves orthogonal curves, or we can also address it as the curves are intersecting orthogonally. So that means at the intersection point, tangent for one curve will be perpendicular to the tangent of the other curve, and we know that perpendicular line of tangent through point of tangency also considered as normal. So that means at the point of intersection, two orthogonal curves will have tangent of each other as normal to themselves. Okay. So in particular, if I do not bother much about normal, we know that if these two curves are circle and the two tangents are perpendicular, then tangent for one circle will pass through the center of the other, because from the point of tangency, if we draw perpendicular to tangent, that pass through the center of the circle. So if we consider that we have been given with two circles, x square plus y square plus 2g1x plus 2f1y plus c1 is equals to 0, and x square plus y square plus 2g2x plus 2f2y plus c2 is equals to 0. These are intersecting orthogonally, and we need to establish the condition on coefficients under which we can have it true. So we can simply think of such a diagram. If the two circles are orthogonal, then at the contact point L, or at the intersection point L, tangent for the green circle will be passing through the center of blue circle, and tangent for the blue circle will pass through the center of green circle, and hence the two centers P and Q along with the intersection point L will form a right triangle. Now we know the coordinates of the centers. As per the equations given for the first circle, the center is minus g1 comma minus f1, and for the second circle it is going to be minus g2 comma minus f2. Also from the equation we can identify the radius of the first circle PL is root over g1 square plus f1 square minus c1, whereas radius of the second circle QL is root over g2 square plus f2 square minus c2. And as due to orthogonality, we are getting a right triangle over here. So the side lengths must be satisfying Pythagoras theorem. So PL square plus QL square is going to be PQ square. Is that okay, this part? Now using the coordinates of P and Q, we can have the distance PQ and square of that. So we have got G2 minus G1 whole square plus f2 minus f1 whole square is equals to sum of the squares for the radii, that is g1 square plus f1 square minus c1 added to g2 square plus f2 square minus c2. Okay, and hence simplifying, we have got the condition of orthogonality as 2g1 g2 plus 2f1 f2 is equals to c1 plus c2. Is that okay with everyone? So whenever we'll be given with two circles, by identifying this relation among coefficients, we can establish their orthogonality. Or on the reverse note, if we've been said that two circles are orthogonal, then their coefficient must satisfy this relation. Let's have a look what type of questions we need to address. For example, let us consider we need to find lambda if circle x square plus y square minus 4x plus lambda y minus 6 is equals to 0 intersect this second circle x square plus y square plus 3 lambda x minus 8y minus 14 equals to 0 orthogonal. So we don't have much things to calculate for. As per the equation, we can believe my g1 is minus 2, f1 is lambda by 2, c1 is minus 6, g2 is 3 lambda by 2, f2 is minus 4, and c2 is minus 14. As the circles been said orthogonal, so we will directly go for using 2g1 g2 plus 2f1 f2 is equals to c1 plus c2. So this is g1, this is 2g2, this is 2f1, this is f2, and their addition is going to be c1 plus c2. And from this relation, we can get to lambda is equals to 2. So how to use this idea, is that clear to all? It is simply a single information based equation. When you will be said about orthogonality, your circles is supposed to carry some parameter in one or more position in the coefficient, and by satisfying the condition of orthogonality, we can decide the value of the parameter used in the coefficients. Okay. On a similar note, if I consider another question, find the value of k such that x square plus y square minus 2x plus ky plus 2 is equals to 0, and x square plus y square plus kx minus 2y plus 6 is equals to 0 are orthogonal to each other. So on the basis of this information, we need to have the value of k. Can you all solve this question very quickly and can tell me the value of k? Calculate it very quickly. Have you all followed what to be done?
Yes, sir.
So go for it very quickly and tell me the value of k. For your solution time, I am keeping a pause on the video. Okay. When you are done, then again we will start recording.
Sir, no possible value of k কারণ minus k যদি হয়ে যায় তাহলে radius আপনার imaginary হয়ে যাবে।
Very good. So that is why I said k is equals to minus 4 is the right calculation but wrong conclusion as an answer. Okay. If we go by simply the condition of orthogonality, over here the data says g1 is minus 1, f1 is k by 2, g2 is k by 2, and f2 is minus 1. c1 was plus 2, c2 is plus 6. So if we go by simply the condition of orthogonality, so 2g1 g2 plus 2f1 f2 is giving us minus 1 into k plus k into minus 1. That's equals to 2 plus 6 gives us k is equals to minus 4. That's right calculation. But if k is minus 4, then radius of the second circle is appearing to be root over minus 2 square plus minus 1 square minus 6, which is not real. It's root over minus 1. So k is equals to -4 will make the second circle not feasible. And hence, for no real value of k, we can have these two circles orthogonal. Okay. So this is a bit trick-based question. Most of the time, whenever we have been asked about the value of parameter, usually students jump into solving by the condition 2 g1 g2 plus 2 f1 f2 is equals to c1 plus c2. Right? That's the condition of orthogonality. But apart from condition of orthogonality, you also need to be sure that the value of the parameter is also going to make the circles feasible, means their radius should be non-negative. Now you might ask, sir, why haven't you checked in the last question? In the last question, you can identify the constant terms were of negative sign. And when your constant terms are of negative sign, your root over g square plus f square minus c can never be negative, right? So that is why we can be very sure that whatever value for lambda we have found, that's going to give us feasible circle, and we haven't checked. But over here, you can identify the constant terms are of positive sign. So root over g square plus f square minus constant term may or may not be positive. And hence, even after having the value k, when we check for the radius for the second circle, we have found that it's not real. And hence, there cannot be a real value of k which can make them orthogonal. Because for conditional of orthogonality to be satisfied, we need to have k is equals to -4, whereas that's not going to make the circles feasible even. At least the second circle we have identified, it's not feasible.